5 common RAG challenges solved, technical insights for building reliable AI agents. It's my pleasure to hand the mic over to Nina Lopatina, our lead developer advocate.
Welcome, everyone. Excited to share with you 5 common RAG challenges that we've solved here at Contextual and sharing the technical insights underlying those. I'm Nina. I have been working in RAG for the last couple of years or so. I've definitely set up vanilla RAG systems myself, and these are actually challenges that I faced when I was doing that. I've been working more broadly within NLP for the last 7 years, starting at In-Q-Tel, a strategic investor, leading a data science team there, and previously getting my start in machine learning in my neuroscience research in reinforcement learning. So it's actually been very fun to see those two fields, NLP and reinforcement learning, come together for LLMs. So to get started, I'll just walk through everything that we'll be covering today. So I'll talk a little bit about what contextual AI is. I will share how we set up this comparison between our RAG and the vanilla RAG. And then I'll go through these top 5 challenges, showing demos of each. So image-based queries, acronyms, table lookups, negation, cross-document queries, with a bonus 6th challenge of attribution. I guess, spoiler, contextual outperforms vanilla RAG for all of these, but I will talk about how we've engineered our system to enable that to happen. And then I'll highlight the specific components of the system that are key for each of these specific challenges. So to kind of level set at the start, let's talk about what RAG is. So retrieval-augmented generation is how you share context with a large language model. And so you'll be retrieving content from unstructured documents or databases that are going to be stored in your vector database. And then that retrieved context is going to augment the generation of your LLM so that you have accurate responses contextualized to source data within your RAG application and agents. And so contextual provides this context layer that lies between those data sources and that experience layer. So we focus on things like query execution, agentic search, data management that enable things like chat, agents, APIs, and workflows. Just at a pretty high level, the way that our RAG pipeline works is we start with the data sources, structured or unstructured data, either loaded directly or through one of our connectors. We have a document understanding pipeline that ingests your data and stores it in a data store. And then our RAG agent, it goes through a mixture of retrievers, a re-ranker, and then our own grounded language model, which are components that we all jointly optimized. And then this content is then output either in our GUI, in an API, inside your app, in MCP or A2A. And then we have a number of different options to specialize the RAG system with system prompts, hyperparameters, fine-tuning, or evaluation. One thing I just want to touch on before we kick it off with the demos is, why is RAG still hard? Why are we still talking about RAG challenges in 2025? There's a lot more buzzy topics we could be talking about, but it turns out that to really take advantage of a lot of the most recent technology, things like agents and agentic frameworks, you really need to have this part be really dialed in. So errors propagate throughout a system. And so, as much as we'd all like to be just focusing on the business critical AI use case, when you start with those components of the extraction pipeline, production level accuracy, scaling and production, it turns out that there are a lot of different things that you need to get right for that to be robust enough to underlie any applications that are built on top of it. So you have to think about connectors, chunking, metadata for the extraction. For accuracy, you really have to think about re-ranking, filtering, vector databases, where your hallucinations coming from, the Q&A evaluation data set. And then for scaling, you have to think about guardrails, latency, entitlements, evaluating new models. They could be coming out faster and cheaper, or they could be worse. And so there's really a lot to take on for having really accurate RAG. And so the comparison that I'll be demonstrating today, on one hand, we'll have our RAG platform, which you can set up in 15 minutes or less. And we'll be comparing that to a vanilla RAG system set up in the open source with open source document pre-processing, face vector database, that's Facebook AI semantic search, and then a quantized llama model. And so it's really difficult to kind of have an apples to apples comparison here because, Contextual is a paid platform, although we have a very generous $25 free trial, so you can try it out. The open source is free, but then hosting it can have extensive costs. And it's actually much faster to set up Contextual than the vanilla RAG. These were both kind of set up to do quick prototypes, but the Contextual system will scale to production immediately versus the vanilla RAG here is not production ready. So it was kind of difficult to come up with an apples to apples comparison. So we just kind of went with a common starting ground for folks starting with RAG. And then for both of these systems, we've used the same data and put in the same queries. And so the first challenge that I'll demonstrate is image-based queries. And so, images have been a challenge, my whole time in NLP. I think there's been a lot of progress made more recently. You may need like a subject matter input for the captions to be the most relevant to your documents. And so here, pulled from our parser blog, we have an example of some pie charts and our figure caption capturing a lot of these data points accurately, whereas other approaches may not capture it. And we actually also allow customization of that prompt where that subject matter expert or further guidance can be input. So our first document set that we'll be looking at are some info sheets for some lab safety and chemicals. And so these kind of have like weird formatting and they have different symbols on them. And then in our vanilla RAG notebook, I've set up the RAG system here, and I'll start with some queries that I ran earlier just for the sake of time to go through some of these examples. So a very simple query you can try is just to get an emergency number of a chemical organization, Chemtrec, and a vanilla RAG system can very easily pull that information out. So that is something that's contained in one chunk and is contained in the text. These kinds of things are pretty straightforward. Our RAG system works for this kind of content. And then our next query is going to be identify all the products in your database whose hazard pictograms include a flame symbol. So now we're looking for a specific image. And we know the correct response from looking at the data is calcium metal and calcium carbide. The RAG system definitely names items that are flammable, as I believe, but none of these are actually in our data set. So vanilla RAG systems really don't have a lot of protection against hallucination. They have their parametric knowledge that they'll try to pull in to try to be helpful, even with that when that information is not specifically in the data set. And now we'll go to my Contextual app. I've set up a few agents in advance, and here's our query here. I set it up with suggested queries just to make it easier. And this takes just a few minutes to set up in our GUI or via API. And here we have our responses, calcium metal, calcium carbide, and you'll notice these little numbers in a circle. So this is actually our attribution. So this will actually show you where in the document this information came from. So you can see for calcium metal, this little flame symbol here. And then for calcium carbide, similarly, we have flame symbol that it picked up on for that response. Great. Now, our next challenge that we'll talk about is acronym disambiguation. So documents omit expanded forms of acronyms. They can't infer the meaning without explicit context. And, there's similar acronyms. The same acronym can have multiple meanings. So there's MVP, minimum viable product, most valuable player. So we'll go back to our chemical examples here. Our first question here is summarize the SDS for Benedict qualitative solution. That is, SDS is a safety data sheet. That is the whole document. And here, this is a very short summary that just has like very random points from that document, going back to the same query within Contextual. We've retrieved information that actually spans the whole document because it was able to understand that SDS is referring to the whole document, not just the particular section where SDS is shown. So this is very long. It has multiple sections of the safety data sheet that it's pulling in for the summary and sharing citations. Going back to our vanilla rag, another question is, which chemicals are regulated by International Air Transport Association? And this is, an intentional challenging question. This phrase does not appear in the document, only the acronym appears in the document. And so the vanilla rag system just has a general response about what kinds of things IATA regulates in general. And going back to our agent, if we ask the same question, it has our response for the two chemicals that are regulated. And you can see in this section here, it pulled out the IATA info, which I forgot exactly where it was located, but it's in this section here. Oh yeah, here, up here, the IATA here. So we just demonstrated images, then acronyms. I actually have a fun little demo that combines those two. So this is for semiconductor info sheet. So I'm going to ask the question, how many PCIe slots on the motherboard? You'll notice we're not really phrasing these super carefully because that's not how people type. Here, the response is there are 6. And if we look at the citation, they were pulled from this diagram here. And so we have the PCIe slots up here. So there's 1, 2, 3, 4, 5, 6, and every other slot is something different. So here we were able to both extract this information from an image, which is really critical if you have technical documentation. That's one of the use cases that we support really well. In this example, how many 16-lane PCIe slots are on the motherboard? There are indeed 3 of those here. So once you unlock images and acronyms, there's a lot more depth you can pull out of the documents that really lets you answer queries about anything in the document. Moving on to our next challenge. So tables still have some challenges around them. So if your table is really large, if you're chunking it, it's going to be difficult to extract that information. If you're not preserving the structure, if you have unreliable extraction of the values, and if you don't have table-aware modeling to retrieve those specific cell values, all of these things will be challenges when you try to answer queries that relate to those tables specifically. And so for this challenge, we have a different document data set. Now we're going to be talking about movies. So for movie info, we have a 241-page table that is a table of Rotten Tomatoes ratings. It's a pretty simple table. It has titles, URLs, release dates, critic scores, and audience scores. But most critically, it is a very extensive document set. And then we have a few other documents around movies. And we'll try a tabular lookup with our vanilla rag. Name some movies with a 100% critic score, but not a 100% audience score. And it will list movies, but these are actually not the correct scores. It just made up those scores. And we can check that when we go to our movie agent here and ask the same question. So we're looking up values in 2 different columns of that table. And here we have a number of different movies pulled throughout that document with citations. So let's see, we've got The Butcher, which is here. Yep, 100%. We have Toy Story 2, which is right up here. Yep, 100%. And so these movies actually fit the criteria of the query. For another example, we have this question, name some movies with both 100% critic score and 100% audience score. And there's actually no movie that satisfies this, but our vanilla rag system, I guess it indexed on the word score. And so it shared titles of movies that have the word score in them. That's not at all what we were looking for. If we go back to our contextual agent, it's looking for documents that support it, and it is finding there are no movies with perfect critic scores and audience scores in its data set. It does share a few interesting, helpful data points like this movie Moving On. It has a 100% critic score and the audience score is missing. So that could be interesting. Southern Gospel had a very high score, close but not perfect. But of course, the key response here is that there's no movie that fits this criteria. Our next challenge will be still looking at this movie data set, and we'll be doing a query with negation. So negation has been a huge challenge in NLP for many years. Vanilla RAG set up similarity search, doesn't have keywords. You don't have logical operators in your retrieval typically, so words like no are not getting interpreted correctly. So in this example on the right here, we have a reference sentence, polar bear DNA may help fight obesity. There's a paraphrase sentence, polar bear study may boost fight against obesity, and a negated sentence, polar bear DNA may not help fight obesity. And all these embedding models, they actually score the similarity between the reference and the negation higher than the reference and paraphrase sentence. And so when you're retrieving, you're often not able to retrieve because of that negation. And going back to our movie example here, name a popular 2023 action movie from the article, the best 23 action movies of 2023 ranked, that does not involve Tom Cruise, and give its ranking according to the report. And going back to our contextual agent, the recommendation here is John Wick, which stars Keanu Reeves and is the #1 rated movie. So it satisfies all the criteria that we were looking for. And then going on to our 5th challenge, cross-document queries. So this is going to be a bigger issue once you're scaling your database. So for a few files, it's easier to find information across different files. But if you have, for example, as I had set up before, like 1,000 different CVPR papers, they may have a lot of overlap in information. And when you want to do comparisons between them, you're not going to find all of the information in one chunk or one document. So for example, if you were searching for which company among Google, Apple, and NVIDIA reported the largest profit margins in their third quarter reports for 2023, there's not going to be any chunk that matches all of these things. So you'll need to find multiple separate chunks and then process them in a multi-hop fashion. And for this, we're going to be looking at some CVPR papers on image segmentation. In our vanilla RAG system, we've asked a question about a segmentation model called Spider, and it uses parametric knowledge to tell us about arachne spiders. So then, of course, it would not be able to answer a question about 2 different segmentation models, Spider and one former. So if we try this in our papers agent over here, it's going to retrieve a lot of different evidence and then compare these 2 models, sharing their key architectural features, main characteristics, and then comparing the 2, which is exactly what we wanted in our comparison. Just a few quick bonus questions that are also common challenges: getting a complete author list from a paper or getting a specific URL. These are often challenges. When we try these in our contextual system, instead of getting one made-up author name, as you might find in vanilla RAG, we'll get this full list and the citation. This is more like how I would want to query an agent. And here's our actual link to the GitHub repo. The bonus challenge, something I've been demonstrating throughout this demo, is attribution. And so that was where I was showing the original files where everything came from. And this is a really big challenge because you have to track that attribution throughout the entire system from that source document to the generated response. And so you need to be able to implement this throughout the full system so that if you had a black box, it would be really challenging. Like if you had a black box component that wasn't designed for this, it would be really challenging and would not enable this kind of attribution, which is super valuable for things like regulated industries where you need to actually show the evidence and have a human look at it potentially, and also just for validating your system beyond the evaluations and things like that, to be able to just look at responses and see that they're looking correct. Now we'll get into how contextual AI works and what enables it to outperform this vanilla RAG system. We start with best-in-class components for every single step of the pipeline. We have benchmark beating performance for document understanding, unstructured retrieval, structured retrieval, grounded generation on the data sets that this is typically evaluated on, which then, of course, also relates to the end-to-end accuracy being the highest on RAG QA arena. To have accurate answers, you need to have all the components be accurate. And then you also need to have them work together. So to combat hallucinations, we have a multi-layered approach. For retrieval, we have a state-of-the-art retrieval system that lets you first retrieve the right information. We have a grounded language model that was specifically trained for the task of RAG so that it is focused on generating responses based on its context and not parametric knowledge. And then we have several additional checks. We have a groundedness check that is happening before the response is generated. And then we have these attribution bounding boxes allowing users to check for themselves. Our extraction parsing pipeline is set up to handle images and tables especially well. So we have a layout analysis component. There's orchestration with multiple ML models and VLMs to OCR the text, caption images, extract tables, and then extract the document hierarchy and URLs. And then we are adding the metadata as well to then create the chunks, set bounding boxes. And this is a big part of what enables these bounding boxes in the UI. For retrieval, we have a more complex system for this. We start with the query, and then translating this, we enable query reformulation, enabling multi-turn, multi-hop query expansion, and query decomposition, so that you have a reformulated query that can add insights about your own acronyms in there, or decompose the query into multiple components if it's a really complex query. None of this is something that a user would have to do. This is just part of the process to then be able to access the right information in the data store, combining semantic search and lexical search. So this combination of sparse and dense vectors is really critical for a lot of the examples I described earlier. We have a filter before we share these retrievals with our instruction following re-ranker. And then there's another filter model, and then an entitlements filter step before you have the final retrieval. So this is an orchestration with multiple LLMs to enable the state-of-the-art retrieval that I was demonstrating earlier. And our re-ranker is the world's first instruction following re-ranker. So you can see in these instructions on the top that you can change those. You can say prioritize professional product reviews, and that will change the re-ranking. You can have show official safety notices first. And so this will really help you tune to the information that you think is going to be most relevant. For the generation step, we take these reformulated queries, share them with the grounded LLM, translate those, and then for the final generated response, we're scoring groundedness and validating those, and then sharing the attributions. This step is also orchestrated with multiple LLMs. I won't get too deep on our evaluation model. It's available. It's not within the overall pipeline I shared, but it's available as an endpoint. And this is part of what we're using to evaluate and allow users to evaluate RAG output with natural language unit tests rather than, less defined metrics. And then for our groundedness checks, let's say if you had a query like what was Google's total revenue in 2023, we would be doing a check with an LLM, with our LM unit LLM. Is this claim grounded in the retrieved context? And so we take that retrieved context, we look at the generated answer, we decompose that answer into claims, and then that LLM judge will compare those claims to the retrieved context and provide a score. Like in this case, yes, these are grounded in the information that was presented. And so for each of those challenges, it's actually different parts of the system that are really key to getting them to work. So for the image-based queries, the extraction and parsing setup is really critical, customizing image captioning and the retrieval. Acronym disambiguation, that can also be defined in our query expansions. For tabular lookups, there's, again, a key part of this is the extraction and parsing, but then also having this mixture of retrievers that lets you retrieve the tables, like table-aware modeling, and then the chunking that was performed for it. For negation, our filter and re-ranker are doing the heavy lifting here. The re-ranker has been trained to take negation into account. And for cross-document queries, elements like multi-hop and query decomposition are really helpful to getting those to work out of the box. And so in conclusion, for myself, seeing how challenging it is to get all of this to work well and having managed a data science team, I would encourage them to treat RAG like any other managed service. You wouldn't train your own foundation model or spin up your own vector infrastructure. So why build RAG pipelines from scratch, especially if you have challenging documents or queries that you want them to be able to answer? So we have a few different ways to use contextual to ship AI agents faster. We have our GUI, which I demonstrated earlier. We have all of the same functionality available in our API. And we also have separate components available for developers via API, the parser, re-ranker, generate, and LM units models that I mentioned. There's a lot of different ways to use contextual. There's a Q&A chat. You can build it into workflows. You can use it for deep research. We have more coming on that in the next month or so. We can also help you specialize for each use case if you're interested. We've really focused a lot on out-of-the-box accuracy, but we also provide use case templates. We have ways for users to optimize prompts, and we have comprehensive manual configs, as well as expert services to help put all of that together. If you want to try it out, you can create a free account at app.contextual.ai and try this out with your documents, with your queries. Here are links to our documentation and example notebooks that walk through setup. And you can always reach out to info@contextual.ai if you have more questions. Thanks everyone for joining. Bye everyone.